Hello, welcome to my channel. Today we are going to review a problem that might come up on one of your coding interviews, but it's very difficult that you are able to solve it in an optimal way if you've never seen it before. So I thought it was interesting to review it here in my channel, and it's called the Maximum Subarray problem. It is a medium difficulty problem. So it is medium level because finding the optimal solution involves using dynamic programming. And as we all know, dynamic programming is not very easy to grasp. It can be a bit tricky. So the problem statement reads, given an integer array nums, find the subarray which has the largest sum and return its sum. So a subarray is just a contiguous, so there can be no gaps. So a contiguous non-empty sequence of elements within an array. For example, we receive an array as input, then we return 6 as the output. Why do we return 6? Because the array with the largest sum is this one right here. So from this number to this number, and if you sum all of the elements, so 4 plus minus 1 plus 2 plus 1, you are going to get 6. So 6 is the largest number you can get from a subarray from this array. And so we are going to review very quickly the non-optimal solution, so the brute force naive approach, to give you a bit of perspective on the more optimized solution. So the strategy here is you basically grab the first element, right? And this becomes the biggest sum found so far. So on the next iteration, you sum -2 with 1. So you get -1. And you have to ask yourself, is this number bigger than the biggest number found so far, which is -2? So -1 is bigger than -2. So -1 now becomes the largest number found so far. And you repeat this with all of the numbers, but then you have to start all over again from the second element. So 1 plus 3 plus 4 plus -1. Then you have to do it all over again from the third element, -1 plus 4 plus -1, etc., etc. So if you are an experienced programmer, you're already thinking probably, okay, so this is a nested for loop. And you're right, you are correct. And nested for loops are usually O of n squared time complexity. So it is not a very good time complexity, it's a bit slow. So the naive approach will be something like you're going to have a variable that's going to be called current sum. We're going to call it local sum. Then we're going to have global sum. We are going to initialize this to 0, and we are going to create a loop and just a regular for loop. Sorry. Then I'm going to copy and paste this. So this is going to be our inner loop. And the inner loop is always going to start from the ith element, because as we said, on each iteration of the outer loop, you're going to start from the next element. So if we are on the third iteration, we're going to start from -3. So -3 plus 4 plus -1 plus 2, etc., etc. So, okay. And this local sum, it always has to start with 0. And what we want to do next on the inner loop is we want to sum the local sum with the j. And there we want to ask ourselves, is this new local sum bigger than the greatest number found so far? So the greatest sum, the global sum. So is the local sum greater than the global sum? We can do this using max. So from math, we use the max function. The max function compares two numbers and returns the biggest. So we can just do this and this. And we assign the result, so the bigger number, to global sum. And finally, we want to return, global sum. So there is something important here that is not really very good to start this variable at 0, because there could be all negative numbers in your array. So what we really want to do is to use a constant, a JavaScript constant, but every language has a constant equivalent to this one, and this is called min safe integer. Yes, I think it's called like this. Let me check just in case. Min safe integer. Okay, so we are going to run, and okay, fine, excellent. So this runs, but as I said, this has a time complexity of O n squared, which is not very good. So now what I want to do is I want to show you the more optimized solution. So for the more optimized solution, the logic goes like this. So this is a divide and conquer strategy. So what we are doing here is we are we are decomposing the big problem into smaller sub-problems. So what is the big problem here? The big problem, or the global problem, is what is the global maximum. So the biggest number, the biggest sum overall. And the smaller problems are what is the local maximum. And to be more precise, the local maximum is either the sum for each iteration. Let's suppose we are on the 5th iteration. So in that case, it's going to be either the sum from the 0th element to the 5th element. So for example, 0 element plus the first element plus the second element, and so on, and up to the 5th element, or the 5th element itself, so the current element. And how do we know which one is the local maximum? So we compare them and we find the biggest one. So the problem here is which one is bigger. So the local maximum is either the sum up to the current element or the current element itself. So which one is bigger? That is the one that's going to become the new local maximum. And then the global maximum is just the bigger number between the current global maximum and the local maximum. So again, which one is bigger? So by solving all of these smaller problems, we can then gradually approach the global solution to the global problem. And that is the strategy followed here by this algorithm. And the name of this algorithm is Kadane's algorithm. Okay, so as an example, you have this array from this example. And so first, the local is going to be equal to 5, right? The global is going to be 0, or really the smallest integer number, but let's say 0 for simplicity. And then on the next iteration, the local is going to be which one is bigger, the sum of 5 or 9, or the current element, and it is 9. And which one is bigger, the local maximum or the global maximum? So 9 is bigger than 0, so 9 is going to be the new global maximum. Then we are going to do 5 plus 4, which is 9, minus 1, 8. So it's going to be 8, or minus 1. So which one is bigger? 8. So the local maximum is going to be 8. But which one is bigger, the global maximum or the local maximum? The bigger one is the global maximum. So the global maximum stays the same, and so on. And eventually we will reach the output, which is 23. So you can repeat this process for yourself by hand, and you will see that it reaches the right solution. In fact, we could do it. We could do that just now. So the next one is going to be 8 plus 7 is going to be equal to 15. So which one is bigger, 15 or 7? So the bigger one is 15. And which one is bigger, 9 or 15? 15. So we then do 15 plus 8, and we get that it is 23, right? And which one is bigger, 23 or 8? So 23. And which one is bigger, 15 or 23? 23. So then we arrive to the right solution. And so that is the explanation. And so let's try to apply this. So we are going to have, once again, a local maximum and local global maximum, right? And this global maximum is going to be number, mean, integer. And this is going to be just 0. Okay, and we are going to have once again a for loop, but this time we are going to have only one for loop. So nums length, the increment, and on each iteration, as I've said, what we want to check is what is the local maximum. So which one is the local maximum? So we have to find the maximum number between the sum, so local maximum plus the current number, it's going to be this one, or the current number. Okay, and finally, we're going to do something very similar here with the global maximum, but this time we're going to compare the global maximum to the local maximum. Okay, and finally, we're going to return the global maximum. So let's run this. Okay, cool. You can see that this has a time complexity of O of n. Let's submit. And that is the maximum subarray problem using the Kadane algorithm. I hope you enjoyed the video and see you next time. Thank you for watching.